In the previous video, we have defined what the loss function is. So we now know what sort of data we expect to see. Now it's time for us to hop into what we call the probabilistic model. So what does the probabilistic model actually mean? The probabilistic model simply states that there is a probability distribution D over input and output pairs. So if we are going to write X as our input and Y as our output, then D is just a distribution over X, Y pairs. So for example, this is our distribution D. And within this distribution, we have a bunch of X's. And also, so X sub n, and also a bunch of Y's. And Y sub n. And so X here is representing our input and Y represents our output. So think of these X's and Y's as just different kinds of input and output respectively. And each of these X's and Y's has their own characteristics defined by their subscripts. So X sub 1 is just a kind of input that has a characteristic or that has characteristics defined by the subscript 1. And that makes X sub 1 different compared to X sub 3, which has its own characteristics as well, which is defined by the subscript 3. The same thing applies to our Y's here or our outputs, which makes Y sub 1 different to Y sub 3. So the probabilistic model states that the probability distribution, or there is a probability distribution that gives us a probability of getting a particular input X paired with a particular output Y. So as an example, the probabilistic model states that there is a probability distribution that gives us the probability of getting, let's say, X sub 1 paired with Y sub 1. So if you look at it, it's like our probability distribution is something that generates data. And that is why the probabilistic or the probability distribution is often called the data generating distribution. So let's take a look at it at a different angle. The probability distribution gives us, think of it as something that gives us a high probability of getting reasonable X, Y pairs, and it also gives us a low probability of getting unreasonable X, Y pairs. To illustrate that, so say for example, this is our probability distribution. And within this probability distribution, there is a law or a mysterious law governing the probability distribution that does not allow input to be paired with an output that has a very, very huge difference in their characteristics. So say for example, X sub 1, or let's just say X sub 31, has a very large difference in terms of characteristics to y sub, let's say 1085. And so this mysterious law that governs this probability distribution makes this pair very, very rare, to the point that if you get this kind of pair, it becomes unreasonable. On the other hand, because of this same governing law within this probability distribution, there will be a high probability of, say, getting a pair of, say, x sub 10 paired with y sub, let's say, y sub 15. And in this case, it's reasonable. To give you a more concrete example, and also like to see in which cases y input and output pair becomes unreasonable, let's consider the following examples. So an input and output pair becomes unreasonable when x, or the input, is unusual. So for example, we have a course recommendation system, and that system will just, given a course, will just predict whether or not a specific student will like or dislike the course. So the input is the course, and the output is like or dislike. So for a course recommendation system in computer science department, you have to keep that in mind, that the course recommendation system is used in the computer science department. It will be very unreasonable for us to get an input or a course with a title of geometric and solid modeling. That is because the course recommendation system is under computer science department, and so chances are we are only getting courses that are related to computer science, like AI or software architecture or data structures, and other subjects under computer science. Another case wherein we would get, or that would make an input and output pair unreasonable, is when y, or the output, is unusual. So say for example, for the same course recommendation system, we have Alice. And let's just suppose Alice takes AI, the course AI, 100 times without remembering it. Like she takes the course AI 100 times and she does not remember anything about it. And then each time she took the AI course, and to be more specific, each time of those 100 times she took the AI course, she rated it +1 or +2. She never had rated it below 0. That means for all the time that she took the AI course, she rated positive to the same course over and over again. Now, why will then become unusual if somehow Alice, after taking AI, rates it as -2? And that will become something that is unreasonable. So that's just like the idea of the probabilistic model, stating that there's a probability distribution that generates reasonable data. And that's it. So, do we know what D is? We have to remember that we are not making any assumptions about what the distribution D looks like. And also, we have to keep in mind that we are not assuming that we know what D is. And to end this video, perhaps the hardest thing about machine learning is that we don't know what D is. All we get is a random sample from it, which is our training data. And that's it for this video. See you in the next one, wherein we're going to be talking about the expected loss. So again, thanks for the time and see you next time.